it's just a process of coding something in a way that nobody can understand it if you don't have the tools to decode it back or decrypt it back, right? We had also something called public key and private key. Public key and private key. So each one, instead of having this concept, we can use it better. Right? So each one will generate his own, depending on the algorithm here, he will generate two keys. One is called public, and one is private, right? And this one also will generate public, and he will generate private. And if you think about it, problem is solved. Using this asymmetric thing, well, instead of coding something and send it to this one and this one gonna generate or whatever, don't know about it, what we do, he will generate his own two keys. One is public and one is private. And as we said, the private, he will be the only one who have it. Nobody have this private. All right? Nobody have this private. And the public, he will share it. He will share it with everybody, even with the hackers. We don't care. Right? Even if someone gonna catch this, we don't care. So he will give his public key to this guy. And this guy, he will give his public key to this guy. And you remember, when you encrypt something with this public key that I gave it to this guy, right? So this guy here is sitting here, and I shared my public key with him. And if something is encrypted with this, it's just the private who can solve it because it's an asymmetric, right? It's just the private who can solve this one. That's good. So if I give him my public key and he want to send me something, what he gonna do? He gonna encrypt that thing with my public key. And he will send it. But nobody have the private key to decrypt it because I generated both of them, and I give him this part that he can encrypt things. And if he send me back things encrypted with this, I'm the only one who have the private to decrypt it back. And he will do exactly the same. He will share his public key. If I want to send him something, I will encrypt it with the public key of this guy, and I will send it encrypted back to him. But he's the only one who can decrypt it because he have the asymmetric key to decrypt it. That is called private key, right? The concept is wonderful, and this is how everything is encrypted now with a high security. I told you, even when you use SSH, this is what you use. Okay, you access your bank account, whatever. So this concept here contributed to a really huge improvement of security on the internet. Well, still tricks. We can trick things, right? There's always kind of attack devil ones that we can stole something from someone. But I mean, in general, in the basic way, this is a huge concept that we developed that we can now communicate securely on a public network. Right? So VPN is kind of a tunnel. You create a tunnel between two spots, and you will talk inside that tunnel. So even if here is everybody, but they will not be able to get the information that they are from here, right? It's called tunneling, VPN tunneling, right? So this encryption, we can imagine that this encryption, it's a kind of a tunnel opened between one part and another part, and they can talk to each others without having a security issue. Well, let's see here talking about. So VPN are virtual networks that are logically defined for secure communication over public transmission system. For example, a national insurance provider could use VPN on the internet to serve its agents' office across the country with a secure access to its database at the national headquarters. So from the national headquarters to the offices, the data is encrypted. When we get access, send us some request from that database, the data come back encrypted. By relying on the public transmission network already in place, VPNs reduce the expense of having a lease private. We're gonna talk about this when we do the next chapter of the one, right? Because imagine if I want to have a private tunnel or private way of communication from one point to one point. Imagine that I have my headquarters at London, in London, and the office in Montreal, right? Or Toronto and Montreal, or even Montreal here downtown and somewhere else, right? And I need that private kind of communication. I don't have a choice. If we didn't have these VPN things, it's gonna cost a lot because I need to build my own wires. This is what we call it a lease, private point-to-point connection between, right? So I'm gonna pay a lease for a wire that I will use that, a link from a router to a router, physical one. This is a lease, and this is gonna cost you an arm or a kidney, right? This is a lot. This is very expensive. So this VPN reshaped the way of communication and solved the problem of money, because it's not everybody who are able to, it's not any company who is able to get this kind of equipment. And the leased communication point-to-point connection between office and national headquarters here, right? It's going to cost you a lot. Even if you have the money to buy the equipment and the kilometers and whatever, you will always pay lease for that. Even if you build it by yourself, I mean, you need an authorization from the government first. And after, if you establish that, if it doesn't exist before, right? So if you establish that with all the equipment and the technicians, engineers, and the trucks and whatever to build that connection through hundreds of kilometers from one point to one point, you need to still pay a lease for the distance that you are using in a country, because it doesn't belong to you. I'm using a wire in 1 kilometer. I need to pay a lease for that 1 kilometer of space that I'm using in my country for that wire, right? It's not just put a wire and you're good, right? That distance is public distance, and the country or the government or whatever, he's leasing to you that space and giving you authorization to do that line of connection. Okay, so it costs a lot. Okay, there is companies that they work on that. So you don't need to go and do stuff by your own. You pay that company and it's gonna build that infrastructure for you. Or there is companies that they already have infrastructures from somewhere to somewhere. So you can go and pay them a lease and you will take a line, right? VPN solve that problem, because we can talk in front of everybody, but nobody gonna understand, right? To ensure VPN can carry all type of data in private manner over any kind of connection, special VPN protocol encapsulate higher layers protocol in a process known as tunneling. So it's a VPN tunneling. Just as there are two remote access services protocols, SLEEP and PPP. So those were the first protocols that we use to connect someone to someone, right? Or point to point, and use this protocol. This is a really old one here. Analog communication, digital phone and digital line started using PPP, point-to-point protocol, developed by Microsoft at the time. International private leased circuit. Yeah, leased international private leased circuit. You can get that. The circuit is already built between all the routers, right? So maybe all you need this circuits, what we call the circuit. Davinder talked about something interesting here. It's more next chapter, but you are here, right? You are here. This is your headquarters. And you can build a line to get to the ESP. So you see, this is just a small part. But I will not build a line if I go to London. I will not really build a line to London, right? Or Toronto or whatever. The providers here, they already have many routers and using, for example, MPLS or whatever, and they will lease to you a link between these two routers to pop up in Toronto the most close to your offices, for example. And after you can build a line here, your own line from the provider too. If you don't have already a free line that he can provide you, right, then you're going to pay. What we call a circuit, when you say international private, international is when you go to London. And here is national circuit, right? So what we call a circuit, the circuit is that routers that they're gonna lease and dedicate to you. See, it's kind of a circuit of communication. So the data gonna pop up somewhere here and gonna pop in here and pop up another way through that provider. And this is what we call a circuit. This is what we call a circuit, right? So a lease circuit, you're gonna lease and pay lease for this. And same thing if it's international, so it's the same thing. You're gonna pass through backbones, whatever, and mini providers maybe. So all the circuits here, and after you have some other backbone communication to go here and so on and so on. Right? In India, it's called NLD, National Long Distance. Yeah, provided by many providers. Yeah, I don't know what's called here in Canada, but this is exactly what we're city, for example, right? So it doesn't have to be international. We're talking about the concept here. Now, after it depends the need of the distance, of course, this is what we call the circuit. This is just told you about because you use the term of circuit, and technically this is the correct term. It's a circuit leased circuit. All right. So before it was just two protocols, ASLEEP and PPP, that they were not encrypted, have any kind of security or nothing, right? There are three primary VPN that provide the tunneling security. They are the point-to-point tunneling, PPTP, point-to-point tunneling protocol, right? This one working layer 1, that's it. Layer 2, we can encrypt, tell the layer 2. It's called the LT2P, so layer 2 tunneling protocol, layer 2 tunneling protocol. And we have SSTP. Where is it? I didn't mention it here. Yeah. So this is the Secure Socket Transport Protocol. And SSL and TLS, of course, the TLS is the improvement of SSL, a transport layer security that we can use also to transport things encrypted through VPN. So a secure socket transport, SSTP, I talked about it. Here is didn't see it. I saw just the SSL at the end. I jumped this one. Okay, so secure socket. So this one can secure tell the socket. See, the socket is on almost layer 4. So here we are encrypting even the IP. Okay. Imagine when you encrypt IP, how the hell the router is going to understand the destination because it's encrypted, right? So there is a lot of work in there. There's a lot of other protocols that they can do that. SSL also encrypt that layer 3 using IPsec, right? IP security. Okay, so imagine if I have, you remember the header? So now we are not talking about encrypting data and the blocks. We are even talking about encrypting the headers of, so I can hide my IP is encrypted, and so on and so on. So the tunnel is much more much more secure. Okay, so we have some kind it's encapsulated on top of it to use it for the sessions and the streams of transport and the IPs and so on. They are not encrypted, but the data is encrypted inside. And there is better than that. There is the tunnel what we call a tunnel is when even the data is encrypted, even the headers, even the informations of these streams, it's also encrypted. So we don't know even from the data is coming and where it's going. You see, just bits that we can understand. Okay. All right. What this encryption do, or how we can secure the data online? We need to take care about four things that they are really important. So this one, and this one, and this one, and this one. To be able to create a tunnel that is secure and we exchange the data through that tunnel, we need to take care about four things. The first of all, the authentication. The authentication. What the authentication do? It validates that the data was sent from the sender. So nobody can trick me. So nobody can trick me, right? It validates that the data was sent by the sender. So how I can prove that this data was really sent by this guy and I'm not trying to talk with somebody else. I have two guys here communicating. Or maybe there is a really bad guy here, right? A devil one that he will try to talk to me with the identity of this guy. So I need a process to verify that it's really this guy that I'm talking with. Okay? So the data is coming exactly from this guy, that he is trusted. That he is trusted. So validate that the data was sent from the sender. We can use pre-shared key entered manually, for example, right? So if I put some password here on the data, and the password will decrypt it here, it's the same password. Well, this guy don't know about it. I'm pretty sure that the data come from this password, right? So we can use it as a kind of a pre-shared key. So it's a key, it's kind of key, but pre-shared with someone, right? So we'll tell him, hey, you're gonna find this code written inside QWERTY1, right? If you find that, you know that it's me who sent the data, because nobody know about QWERTY1, right? Manually into device, or the RSA signature certificate. We use the same protocol of RSA, of this private public key, right? The concept of sharing key, and we're going to encrypt the certificate. What is a certificate? A certificate is the information about the sender that he is trusted. Okay, we can build our own certificate, or when we talk in the public, for example, you go to the server of Microsoft, who the hell know that you are talking really with the server of Microsoft? Because the certificate is the certificate of Microsoft. There is companies that they have their own business on that. The most known one, for example, is VeriSign Trusted or Thauti, right? Thauti is more in the public key certificate working. What is the X.900 X.509, right? The norm of the public keys. Or the digital signature of Diffie. We use Diffie-Hellman to use a digital signature. So we use this encryptions for certificates or digital signature of any data of any device, and we exchange that. Once the data come, we're going to verify that, right? And verify that it's the same digital signature, so it's the real guy, so it's the authentication is good, okay? Or the certificate. This mean trust me, everybody know me. This is a certificate. You go to VeriSign here, trusted. You're gonna generate a certificate for your own server in the internet, right? And people, when they will talk with your server, they will go and verify this here. Oh, okay, it's Michael Jackson. It's a very famous. I know that guy. Okay, I don't have to be scared. He's very known. Okay, he's famous. Okay, so you can build your own certificate for kind of simple transfer or informations, or if you are offering a bigger service to the public, how the people can trust you because of you are famous, you need to have certificates signed by those guys. So it's kind of a third person here that he's gonna give you insurance, right? So here's me, and I know another guy here. This guy, he is really known. So this is the police, for example, right? So this is the police, and the police have all my data, and they have my ID, right? That it's encrypted. I'm gonna build it there. So when I will try to communicate with you, you will have the data in my police in the police department here, and they will give you the certificate. They will give you the file about me every time. Every time you exchange data, you can check this. You can check this. Oh, okay, it's Hamza. He's not dangerous. We know this guy, right? So he's a happy guy, right? And problem is solved, right? So we can authenticate using these techniques, right? Digital signature or certificates. Where is my Word document? The second point is limiting unauthorized users from accessing the network, the access control, right? Now we are not talking about one guy, we are talking about computers. Okay, so I can use certificate, I can use digital signatures to verify what? To verify the server, right? To verify the device that I'm talking with. But how about this guy? Who can confirm that this guy is really Hamza, right? I mean, the human being, the user, right? So we need a concept of authentication. Using Kerberos, for example, a database access, password and logon, right? Usernames and those stuff, right? So I can verify the user now. Who can have access or not? But the person. Now I trust the machine is not another machine of a hacker, but who can tell me that this guy have the right to talk to me or have the right to check what I'm giving to this company or check my database or use my my application software or whatever. So what is the authorization that this guy have? We need a control access. Okay, so limiting unauthorized users from accessing the network. Confidentiality. This is all the encryption part. Okay, so a VPN or a secure communication need to be authenticated, need to have an access control to verify that that guy have the right to do that, and confidentiality. The data should be encrypted. The encryption that we use now is more in this advanced encryption standard. This is the algorithm. You see this cipher that we talked about it, the steps move 3 right or something like that. This was developed by US Army at the time. We have many other algorithms, guys, but this is one of the most strongest we have now in the world. Okay, is one of the most strongest and advanced that we have in the world. This is what we use on the bank accounts and all secure things. It's called AES or Advanced Encryption Standard. We have DS, we have triple DS, right? 3DS or triple DS. Those are the symmetric ones. The symmetric. Remember, this Diffie-Hellman, this RSA, we use it on secure on certificate, we use it on digital signature, we exchange the keys with, right? We exchange the keys of metric stuff, and after the communication will be encrypted symmetrically. We'll not stay on that asymmetric kind of communication, because the asymmetric is just the way to solve that first problem we were looping in. How the hell I can give you my key to decrypt with, and I need the key to encrypt it, and how I can give you the key encrypted, blah, blah, blah. So asymmetric solve that problem with the concept of Diffie-Hellman, private and public, right? So I will give you my public, I will keep my private. When you encrypt something for me, you encrypt it with that public, my public, so even the others can see it. They can do nothing with, just in case they want to send me something, right? But they will not understand what anything was being encrypted. So if you use that key to encrypt something for me and you send it to me, I will be the only one who is able to decrypt it back, because I'm the only one who have that private key. I never send it, the private key. I generated two key, asymmetric. One is for encrypting, one is for decrypting. The decrypting one, I would just keep it for myself. I will never share it in the internet. It will never go through the network card. The other one, public, I will give it to everybody, right? You have the key. So anybody want to talk to me on this encrypted channel, he will use that key that I provided to you and encrypt it with and send me back. And that will be the only one to decrypt it back. All right? So this is the concept of asymmetric. We have, I told you, we have a lot of algorithms here, right? But the most known, used, famous one is AES, or Advanced Encryption Standard. We have Bluefish. Bluefish was also, Bluefish algorithm was also very used at the time. And one last point here to make a communication secure that we have to take care about is the data integrity. The data integrity. So we use authentication. Okay, I can verify the machine. Access control, I can verify the people. Okay, have the right or not. Confidentiality, I use this asymmetric and after symmetric way to exchange all the data using many different technologies of algorithms and concepts. RSA also is an algorithm. So I can encrypt my data, but I still have one last problem. Well, the last problem is, who the hell know that the session was not, for example, hijacked here and someone just pushed some data in the middle? How I know? So you see, I verify that it's really the machine and it's trusted. I verify that the guy have the right. My data is encrypted. So I have a way that I can talk with. I established the way that I can talk with, and we are the only who can understand what we are exchanging. I still have one vulnerability here, is the data. Is it really the data that was being sent here, the one that I'm receiving here, or was being modified in its way? Right? I repeat one more time. Data integrity. So we verify the device, we verify the guy, right? We establish roles that we can talk with some language that we are the only one who have the tools to decrypt it back. And we need to verify the data. I need a process to verify that it's really the data that come out here, the one that I'm getting here. It's not mine. It doesn't contain any Trojan, any malware on the background, anything. It's really that data. It's exactly this sequence of bits. You see, it's exactly that sequence of bits that was being sent here is the one that I'm receiving here. This is data integrity. And for that, we use something called hashes. Hash. Online generator. I'll give you some examples here. So what is a hash? A hash is a complex mathematical process, okay, that every time I will put some data on an input. If it's the same, it will exactly give me exactly the same length of hash, and it's exactly the same hash. If I will change one bit, even the data is 100 gigabyte of 0 and 1s, right? If I will change one bit in there, the result will change. Okay. There's a mathematical process, complex one here. We have a lot of calculus to do. But for example, yeah, by the way, the most known ones are MD5 algorithm, SHA-1, SHA-5-200. We have a lot of others, right? This web is very limited here. I'm on the BMO one. Hell is BMO. SHA. See, here is it. Hashes. See, there's a lot. There's a lot. It's kind of something. So the input, Hamza. If I choose, for example, this is a CRC MD5, right? Hamza. Here's MD5. So I have a key here of 64 bits, I guess, or depend. We have 128, we have 256, and even shot something. It's not here. File hash. So if I choose a file hash, I need to drag and drop a file here. Because you remember what is file? A file is the same thing as Hamza. It's just a sequence of bits, 0 and 1s. So I can put even the software here and see if that software was being modified or not. If it's mined, if there is something malicious inside or not, right? Because usually when a company builds a software and sell it, they will make a hash public for that software or that file or that document or whatever. They will make it public. Okay. So if I take that file and I will put the file here, I can have a unique sequence of hash, a unique just for that file. If anything will be changed inside, and I mean anything, one bit was 0 become 1 or 1 become 0, not just putting data inside, right? If I change one bit, everything gonna change on the hash. And it's always the same length based on which kind of algorithm we are using, right? So for example, if I take here hash Wikipedia, hash food, hash mark, hash computing, hash function. Right, see? Paste it. Here's the hash of all the Wikipedia content of the hash page. I can take the whole Wikipedia and hash it, and I will have a unique key here. So if I will change, for example, something here, see the hash change instantly. Put 1 here, the hash change, and it's unique. It's unique. Every time this sequence will give me exactly this sequence of hash. For any kind of input of data, depend on which algorithm I'm using. Now, since I have this magnificent technology, right or not? So every time that I'm encrypting something here, I will hash it. Right? And I will put the digital signature. I have the authentication if I'm working with pre-shared key or not. So I will put everything here and send it. So the data, when it come there, this guy will not really read it first. He will not open it. He will hash it first. So he will take that data, he will hash it first, and see if the hash match. If the hash match, show the data integrity there, the one that I'm receiving. If the hash don't match, we have a problem. Something wasn't correct during the transportation, right? So we use these hash functions, to verify the data integrity. Once we provide these 4 main, so authentication, it validates that the data was sent from the sender. The access control, limiting unauthorized person, so the person is authorized, we can verify that. Confidentiality, We use all these algorithms, ciphers, and stuff, and the key, public key, symmetric, asymmetric ways to encrypt the data. And also we use the hashes to verify that it's exactly the same data that was being sent from the other side is the one that we are receiving. Okay, good. Let's talk about these protocols quickly here. Point-to-point protocol, the less secure one. This is the less secure one. Is a layer 2 protocol developed by Microsoft that encapsulate PPP. So remember the PPP that we had here first, it didn't have any security. It's just the protocol talking from one point to one point protocol. This is the name of it, point-to-point protocol. Now, point tunneling protocol. So we have an encryption that happened on layer 2 that encapsulate PPP data frame, so it comes at not higher than that, right? So that the frame can traverse the internet masked as an IP transmission. It uses a TCP segment at the transport layer. PPTP support the encryption, authentication, and access services provided by routing and remote access services, the one that we were using on our servers. We just used it on the lab, right? PPTP use a generic routing encapsulation, the GRE. We call that GRE tunneling. GRE tunnel. The concept of GRE tunneling was made by Cisco first, right? But PPTP used the GRE tunneling protocol to transport PPP packets, the Microsoft point-to-point encryption, MPPE, Microsoft point-to-point encryption protocol to encrypt the traffic. Now we are talking about encrypting the traffic. So on top of that, this is encrypting the data. Now we are encrypting the traffic, the informations of the traffic, to allow PPTP traffic to pass through the firewalls, for example, or whatever, because of it's encrypted. So the firewall will block it, right? So we have some protocols here to use with for encrypting the traffic with it. You will need to open the 1723 on the firewall port control, and the protocol ID 47 carry the data on the firewall. So this is how we deal with the firewalls to let this kind of MPPE with the grid tunneling of PPTP. It's the less secure one. Of course, we still use it in some kind of LTP, layer 2 tunneling protocol, more secure than this, is a VPN tunneling protocol based on the technology developed by Cisco. LT2P encapsulate PPP. So you see, it's exactly the same protocol, the one that is not secure. Now we are trying to make it secure using different protocols. PPTP data in a similar way to PPTP, but differ in a few key ways. Unlike PPTP, L2TP is a standard accepted and used by multiple vendors. Is one important thing. So this part here is just for Microsoft. LT2P is for everybody, even Microsoft use LT2P also. But once you use PPTP, you are not dealing with a lot of technologies that they accept this PPTP. So this one is much more universal. So it can connect VPN that use a mix of equipment type. For example, a Juniper router to a Cisco router, a Netgear router, and so on. They will all be able to work on LT2P. PPTP, you need Microsoft staff and routing and remote access. LT2P can connect two routers, a router and a remote access server, or a client and a remote access server. Now we're going to talk about those here, right? We're going to talk about those here. So they can connect two routers. Where am I? Here you go. They can connect two routers and remote access service, or the client and remote access server. LT2P use the more secure IPsec. This is a really secure and good. It encrypts the IPs now, right? So Internet Protocol Security. It's an encryption for the header of layer 3 protocol on the OC model. So for encryption of the traffic instead of MPPE to allow LT2P traffic through the firewall, blah, 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 blah. So this one is integrated on LT2P. So basically when we talk LT2P, we say LT2P EPSEC. What's kind of encryption? LT2P EPSEC. We can use it without EPSEC. It's less secure. We don't have the encryption on layer 3, but we can use it with IPsec, and we're going to have full security of the traffic. This one, open the ODP port 500 for key exchange. See the exchange of the keys? Which exchange we're talking here? The public key, right? The public key. Because I need to give you my public, you need to give me your public, and after I will use your public to encrypt things for you, you will be able to decrypt them back with your private, and vice versa. So the key exchange at the first, and after they will exchange the symmetric key, and they will talk encrypt with the symmetric key. UDP port at network address translation, and the UDP port 1701 on the firewall. EPSEC is a separated protocol that we use on top of LT2P. Is an encryption protocol that defines the roles for encryption. So this is the roles how we encrypt that traffic. Automation and key management for TCP IP transmission, right? So it's the protocol also for the key management. Okay, which one is public, which one is private, and especially if it's in block, right? The key change, a lot of keys, and who's gonna take care and manage all those keys of everything, right? TCP IP transmission, it is an enhancement to IPv4 and is native to IPv6. So it was developed between IPv4 and IPv6. IPsec work at the network layer of the OC module, so network layer 3, and adds security information to the headers. So we are encrypting the header of layer 3 using IPsec. Of all IP packets and transform the data packet. When working as a VPN encryption technique, IPsec first establish a secure channel with encryption. This is what we call a tunnel after, right? So this is secure channel, and all the term is the tunnel. With encryption, then the tunneling protocol usually use LT2P through IPsec. So the LT2P pass through that tunnel. Can be used alone to create a VPN. So we can have just a VPN with IPsec. Okay, we are encrypting just the layer 3, hiding whatever informations of identity of IPs. Provide the tunnel for encapsulation. Three main IPsec protocol headers and ESP, encapsulating security payload, right? So these three, they are what we call IPsec. Okay, these three here, they are what we call IPsec. IKE here, IKE version 2, we're going to talk about it here, is Internet Key Exchange version 2. Okay, so when we do this and this and this, we end up with IPsec. So we can divide it on three protocols. Each one have its own responsibility. It doesn't mean that every time we have all the three of them, right? So I can have IKE with ESP or IKE with AH. One protocol, so what is IKE version 2? One protocol used by IPsec provide a framework, okay? So it's tools, it's like a laboratory or something, or a kitchen framework for negotiating security parameters and establishing authenticated keys compared to authenticated keys. Compared to IKE version 1, IKE version 2 negotiation is much faster. So we have the version 2, we gain on speed of the negotiation. It supports Mobike. What is Mobike? Mobike is one, for example, this is used one situation where you use this. For example, if you have a Wi-Fi, right? You remember that Wi-Fi when we talked about the ESSID we have many access points, and you just log on in one access point, and after you're going to move on the building, you're going to switch from one access point to another one, right? Because you have a mesh. It's the same Wi-Fi, but the access point is different. This Mobike is the technology that allow you, for example, to jump from one access point to another, so you will be already identified from. So the identification will just follow in the second access point and so on. So mobile Ike, which give you almost instant reconnection upon IP address exchange. See? So even if you change an IP, well, imagine if you are in a website, also a security, your bank account or whatever, and your IP gonna exchange in the same time. Imagine even if you are on the bank account and you are switching access in the same Wi-Fi, but the second one will give you another IP address, right? You will not disconnect. Well, you will disconnect, but instantly reconnect. You will not have to go and reconnect by yourself because of this Ike version 2 improvement. Instant changes. Think a smartphone switching between Wi-Fi and 4G. For example, yeah, this is another good example. You are on the Wi-Fi, and after this normal Wi-Fi, and you just jump to the LTE, you are in another kind of network, right? Satellite passing through your provider. You're not at home anymore, right? And you are connecting somewhere. You don't need to go and reconnect on that LTE or whatever. So the connection on the website, on whatever you are doing, it will just keep going, right? So this is the Mobike improvement that we have on Ike version 2. Ike version 2, all the way reliability and state management. Ike version 2 use sequence numbers and acknowledgement to provide the reliability. So acknowledgement and sequencing, we already know this process of TCP, right? The 3 handshake that we had in any kind of communication. Even the Wi-Fi spot, we use the 3 handshake to synchronize the numbers and have the acknowledgement after for all the data stream. So the Ike use also acknowledgement and sequencing. We have the Secure Socket Transport Protocol. SSTP is the most secure one, right? SSTP is common VPN protocol today and is the newest of the 3 protocols listed here. SSTP has the benefit that is used the secure socket layer, SSL, call it SSL, to encrypt the VPN traffic, so it is easy to configure the firewall, allow VPN traffic to pass through. You simply open the 443 for the SSL port number, right? So we secure all the socket here. The socket is secured. The IP and the port number. Here we are more on the layer 4 transport that is encrypted, okay? So even the headers of layer transport, that they are encrypted. We use a SSL for that. So we call it SSTP. Is more secure than this one. Is more portable also, right? Is more portable. So when we use this, we can end up with HTTPS, with SFTP. See, we can take a protocol and we just merge it on that software or whatever. Those are more for remote access, accessing the machine or creating a tunnel. Okay. This one we can use it on the web, right? So your web page, you are on the VPN. When you are using HTTPS, you are checking that website by using your own VPN with the website, but you don't see it anymore. You don't need logon. You don't need whatever. Like in this ones here. This one is used, for example, to give a remote access. For example, I have a computer at home and I need to connect to a computer at DP on Herzing, and I need a secure VPN line on there, or getting access to my own computer in a company or whatever, right? SSL, a secure socket layer, and TLS, transport layer. Yeah, 443 also used. Davinder is saying 443 is also used by HTTPS because HTTPS is using the SSL, right? HTTP is not encrypted. It's port 80, but when we put it on top of it, we are communicating under the SSL now. The sockets are encrypted. We are communicating on the 443. So the HTTP become inside the SSL capsule, and the SSL capsules talk on the port 443. This is why HTTPS secure socket or TLS transport layer security. SSL secure socket layer, TLS. Of course, this is an improvement of SSL. They work together, right? We usually mark it like this: TLS, SSL. Are both method of encryption TCP/IP transmission, including web page and data entered into web forms en route between the client and the server using public key encrypted and are widely known as SSL-TLS or TLS-SSL. All browsers today, for example, Google Chrome, Firefox, whatever, support SSL-TLS to create secure transmission of HTTP sessions by default. The kind of VPN that we can have site-to-site, site-to-site. This means from the external gateway, the router to the router, but here it's not encrypted and here it's not encrypted, but over the public place, the internet is encrypted with IPsec tunnel. So we can open IPsec from this router to this router, and we have a site-to-site. So this is my first site, and this is my second site, and I have a tunnel in between. Remote access IPsec VPN client to site. Client to site is from here to the router here, right? From here to the router here. For example, the RDP that I'm using remote access, right? So from my machine, I go to the router, and after the router, let me go into my computer here. SSL VPN, remote access VPN. So instead of using softwares or whatever, you don't need to use any more softwares. It's included. So if you read here, you're gonna understand. So this one, set up a secure VPN tunnel between R1 and R2, site to site. This one, set up a secure VPN tunnel between PC and R2. PCs use a software like Cisco VPN client, whatever VPN software made for that to get access. Here, you don't need the software. Set up a secure VPN tunnel between PC to R2. No PC software required. You're using your browser, for example, and you get there, right? RDP is more here because you are using the software of Microsoft that's called RDP. That's it. Okay. So when you use Cisco VPN, whatever, OpenVPN, something VPN, NordVPN, you need the software. You need to go buy it, download the software, and log on with your account and pay for it, or maybe it's free. By the way, an advice: never use free VPN. It's bad, right? Because they can reverse it. Everything that is free, it's a joke. So the ones that they maintain the server, they can decrypt your data if you are using a free VPN in the world. Okay. All right, so this one need a software, this one don't need a software. Like, for example, it's integrated on our Chrome browser, Firefox, whatever, or even machine to machine, right? Communication established. We don't really need any software to download and connect to that server, and the server will provide us with a VPN. This is it. It's a small part, interesting one, not that hard, right? Almost technical with the new terms here, a lot of new terminology about the security and the VPN and encryption and so on. So we have mainly asymmetric, symmetric, public, private key, PPTP, less secure, LT2P, more secure, SSTP, much more secure, based on SSL TLS, right? Okay, guys, if you have any question, you have any question, or if you don't have any question, you don't have any question, and we can go, right? There's no labs. The people that they have retake on next Sunday, please keep working on the computers and review your stuff, right? Because next Saturday we should be able, maybe like 90% we should be able to finish the module, right? So I told you last sprint we're going to do the one technology. We will talk about that leased line, right, on VPN or the circuits that we talked about, and you have a lot of other new terminology in there also, right? We're going to talk about the one technology, and even the one wireless technology, the WiMAX, just explaining some basic concepts. That's gonna be our last course or last lecture in the whole block. So I will not teach you anymore after that. I will give you a project instead of teaching you. So the project, maybe if we finish earlier next Saturday, I will give you the project next Saturday. If we don't finish earlier, I can give you the project on next Saturday, right? I will explain to you the project, what you have to do. Remember, the project is a big project, starting from module 1, right? Starting from module 1. So you will have all those stuff that we learned, the practical one, DNS, whatever, DSCP, subnettings, website, bindings, stuff, hard drives, red 0, red 1, red 2, host file, creating users, and everything, right? Everything. So this is about the project. You will have to prepare a full report about that. I will show you how to do a report. Show you a template. I will not give you that. So you build your own, and you need to submit it the last day before the exam. And we're gonna meet on the last Sunday of this class. You're gonna have your exam. You will have 2 or 3 quiz, like usually, and after that you will have a lab exam. Are we good, guys? Any question? Yes, sad face. Well, it depends. It depends where you're gonna go after, right? It depends if you go to the block 3 or block 2, or maybe they're gonna split you, or I don't know. Block 3 you go to Linux. Block 2 you go to domain. Block 3, yeah, good luck with that. So you will go to Linux with Carning. You're gonna be with Carning, or maybe Sahil. I don't know if he's teaching Linux. Exam on date. So we did 2 weeks, right? 1, 2, 3, 4, 5. The exam should be on the 4th, 4th of April. The retake was on the 21. Retake TBC module 4 will be on the 21. It's still on Kaisala. No, I will I will block everybody. It's done. I'm not a teacher anymore. I'm just kidding. Or everybody, of course, we keep in touch. If you need any help or whatever, when I have time, I can get back to you. It's always a pleasure. Malhar, okay, guys. So the exam should be on the 4. You have to submit your project on the 3 before 4 p.m. But I know people, they will say, oh, please, we need 1 more hour, we need 1 more minute, we need 1 more second, we need 1 more whatever. So I will give you to submit it here before 8:30, before starting the last day here, 8:30. You're going to submit your report right here. Okay. Just before the exam. Well, we're going to talk about it. Okay, guys, if you don't have any question, it was a pleasure, like usually. See, he is already prepared for IT. Who is prepared for IT, Marister? See, prepared for it. Yeah, IT. I see it, IT. Yeah, he's already prepared for it. I'm already prepared for it. Well, guys, wish you a wonderful week. Please review, right? Don't let till the last minute, especially the people who have the retake TBC on next Sunday. So get ready for that. You will have, of course, a quiz and the lab to do. Depend on, I think everybody passed the quiz, right? I don't remember, but mainly people gonna do the lab, right? But I think I don't have any retake on the quiz, on the theoretical. Maybe I don't really remember, but you already know. I already put it